This is Unit 5, Lesson 2, Properties of Exponents and Radicals. So our lesson essential question is, how can properties of exponents and radicals be used to rewrite radical expressions? At the end of this unit, you'll be able to use properties of exponents and radicals to simplify radical expressions. All right, so concept, properties of rational exponents. The properties of exponents apply not only to integer exponents, but to rational exponents as well. Now, let m and n represent rational numbers, with a, b, non-negative real numbers. So you still have the product of powers, a to the m times a to the nth equals a to the m plus n. So I have 4 to the 2/3 times 4 to the negative 1/3 equals 4 to the 1/3 power. Quotient of powers, so when I divide, my bases are the same, the exponents subtract. I do the same thing. Power of power, so I'm raising an exponent to another exponent. I do the same thing. I multiply the exponents together. Power of product, AB to the mth power. I apply that power to each of the integers or rational numbers inside the parentheses. And a negative exponent, I flip the base that has the negative applied to it. So in this case, m to the negative mth becomes 1 over a to the mth power. So basically, they just switch whether they're in the numerator or denominator, and the power becomes positive. All right, example 1, use properties of exponents. So how can you rewrite the expression using the properties of exponents? 81 to the 5/6 times 81 to the negative 1/3. So I'm using the product of powers property, so I'm going to add these two exponents together since they have the same base. 5/6 plus a negative 1/3 is really 5/6 minus 1/3, which I can rewrite as 1/2. So 81 to the 1/2 is like the square root of 81, which is 9. So you can rewrite 81 to the 5/6 times 81 to the negative 1/3 as 9. How can you rewrite the expression using the properties of exponents? xy cubed over x to the 1/2 raised to the 2/3 power. So again, I'm using the quotient of powers property. They have the same base, okay? So and it's just the x's that have the same base. So x to the first minus the 1/2, y cubed to the 2/3 power. I simplify that. 1 minus 1/2 is 1/2. Okay, then I use the power of product and power of power properties. So 1/3 times 2/3 gives me the cube root of x and y squared. All right, so let's try it out. How can you rewrite each expression using the properties of exponents? So I have 3 over 3/32 to the 2/5 raised to the 1/2 power. Okay, so I have 3 and 32 to the 2/5, so I can actually take 32 to the 2/5 and just simplify it. Which gives me 4. So this is 3/4 to the 1/2. Okay, this is like saying 3 to the 1/2 over 4 to the 1/2 after you do the power properties, power of powers rule. So 3 to the 1/2 is the square root of 3 over 4, which equals the square root of 3 over 2. Square root of 3 over 2. For B, I have 2a to the 1/3 times ab to the 1/2 times 2 to the 2/3 power. So 2a to the 1/2 power times a to the 2/3 power times b to the 1/2 times 2/3 power. Okay, so this gives me 2a to the 1/2, which is a to the 2/3, and then b 1 times 2 is 2, 2 times 3 is 6, which they simplify, so I'm left with 1/3. Okay. I multiply the a to the 1/2 times a to the 2/3, which is like adding them together, which is 1/2 plus 2/3. Okay, I have to come up with a common denominator, which is 6. So 7/6 or 1 1/6. And this is also like saying square root of a times b. So this is a to the 1/2 5/6. So a to the 5/6, b to the 1/3. Okay. When I simplify this, I get 2a cube root All right, example 2, use properties of exponents to rewrite radicals. How can you extend the properties of exponents to derive the properties of radicals? How can you rewrite the nth root of ab using the properties of exponents? So the nth root of ab equals ab to the 1/nth power. So a to the nth to the 1/nth, b to the 1/nth. So the nth root of a, the nth root of b. So the nth root of ab equals the nth root of a times the nth root of b. You can use a similar method to show that the nth root of a over b equals the nth root of a over the nth root of b. So how can you extend the properties of exponents to derive the properties of radicals? How can you rewrite the cube root of 16 times x to the 5th using properties of exponents? Well, 16 times x to the 5th can be written as 8x cubed times 2x squared, because I know the cube root of 8 is a perfect cube. So 8 and x cubed are factors of 16, and x to the 5th are perfect cubes. 2 and x squared are the remaining factors of 16, and x to the 5th that are not perfect cubes. So when I do that, this becomes 2x cube root of 2x squared. So the cube root of 16x to the 5th equals 2x times the cube root of 2x squared. Rewriting the expressions as 2x times cube root of 2x squared may be referred to as a reduced radical form of the expression because all nth roots of the nth powers in the radicand have been simplified, and no radicals remain in the denominator. Okay. So how can I rewrite the expression, the 4th root of 81, a to the 8th, b to the 5th? Okay, so if I were to do this, a to the 8th has 2 4th roots because 2 times 4 is 8. B to the 5th has 4, so I can actually separate this. Okay, so this is 4, 81. Okay, so 81, a to the 8th, b to the 4th, times b to the 1st power. So 81 to the 4th root of 81 is 3, so I have 3a squared b, and then the 4th root of b. For b, I have the cube root of x to the 4th y squared over 125x. So I can rewrite this as the cube root of x to the 4th y squared over the cube root of 125x. Okay, so that equals the cube root of x to the third x y squared over 125 is a cube root, so 125 times x, okay? So when I do this, this equals x, and then the cube root of x y squared over 5 cube root of x, okay, x y squared, so x can be written as this times root of y squared, and then x cubed over x. So I can actually cancel these out. So I'm left with x cube root of y squared over 5. Okay. So x cube root of y squared over 5. Okay. You want to do everything in your power to get this cube root, this square root, cube root, whatever the root is, out of the denominator. All right, so concept, properties of radicals. So the product property of radicals, the nth root of a product of non-negative real numbers is equal to the product of the nth root of those numbers. So the nth root of AB equals the nth root of A times the nth root of B. So AB to the 1/nth equals A to the 1/nth, B to the 1/nth. The quotient product property of radicals, the nth root of a quotient of non-negative real numbers is equal to the quotient of the nth root of those numbers. So the nth root of A over B equals the nth root of A over the nth root of B, or A over B to the 1/nth power equals A to the 1/nth over B to the 1/nth. All right, example 3, rewrite the product or quotient of a radical. So what is the fifth root of 16 times the fifth root of 8 to reduce in reduced radical form? So because they're the same root with the same index, I can multiply 16 times 8, which gives me 128. I can break that down into a fifth root, which is 32 and 4. The fifth root of 32 is 2, so 2 to the fifth root of 4. Okay, what is the sixth root of 8x times the cube root of 2x in reduced radical form? So use rational exponents. So I have the sixth root of 8x becomes 8x to the 1/6 power, and the cube root of 2x becomes 2x to the 1/3 power. Then I can multiply, okay? So this tells me I have 8x times 2x squared to the 1/6 power. I got to write it using a common index. So basically, I changed 1/3 so it had a common denominator. Then I could use this 2 down here, so the numerator became the exponent for the 2x. It's still raised to the 1/6. Then I can simplify. So then I have the sixth root of 32x cubed, which I can't simplify any further than that. All right, so what is the cube root of 2n over 9m in reduced radical form? So to rationalize the denominator of an expression, rewrite it so there are no radicals in any denominator and no denominators in any radical. To rationalize the denominator, find a factor so that a cube root of a perfect cube is created. So the cube root of 2n over nm becomes the cube root of 2n over the cube root of nm. I multiply both sides by the cube root of 3m squared. So 9 is a factor of the perfect cube 27, and m to the first is a factor of m cubed. Multiply the denominator and the numerator by the cube root of m 3m squared to create a perfect cube. So basically, what do I need to multiply this by to get rid of it? So 9 times 3 would give you 27. Cube root of 27 is 3. M times m squared gives you m to the third power, which gets rid of the m. Okay. So this gives me, I then multiply the top two, so 3m squared times 2n is 6nm squared. 27m cubed becomes 3m. Okay, I can see if I can simplify anything else up here, which I can't because nothing is a perfect cube. So I get the cube root of 6nm squared over 3m. All right, so let's try it. What is the reduced radical form of each expression? The fifth root of 7 over 16x cubed. Okay, so the 2 to the 5th is 32, so that doesn't work. So I need to multiply by something that will get me a fifth root. Fifth root of 32 would give me 2. So I need to figure out what I need to multiply by. So I need to multiply 16x cubed by 2x squared. Get rid of this, okay? So fifth root of 7 over the fifth root of 16x cubed. I'm going to multiply by the I'm going to multiply by the fifth root of 2x squared. Fifth root of 2x squared, which will give me, okay, so this gives me the fifth root of 7 times 2 is 14x squared. And then fifth root of 32x to the fifth. So this equals fifth root of 14x squared, which can't be simplified any further, over 2x. Fourth root of 27x squared times the square root of 3x. Notice they don't have the same index, so I'm going to rewrite them using exponents. So then I'm going to change the 1/2 so that it has the same denominator as the 1/4. So 27x squared stays the 1/4 times 3x raised to the 2/4 power. This is really like saying 27x squared to the 1/4 times 3x squared to the 1/4. So then I have 27x squared times 3x squared to the 1/4 power, which I can rewrite as a radical. So I have 4 27x squared times 9x squared which is the fourth root of 27 times times 9 is 243. 243 x to the fourth. Okay. 243 can be written as 81 times 3 times x to the fourth, which the x to the fourth will come out. The 81, the fourth root of 81 is 3. So 3x to the fourth root of 3. All right, example 4, add and subtract radical expressions. What is the sum of the square root of 20 minus the cube root of 16 plus the cube root of 250 minus the square root of 5? So like radicals have the same index and the same radicand. Only like radicals can be combined with addition and subtraction. Okay. So I can combine the square root of 20 and the square root of 5 and the cube root of 16 and the cube root of 250. So I group radical terms with like indices. So I have 2 square root of 5 minus square root of 5 minus 2 cube root of 2 plus 5 cube root of 2. I simplify them. 2 minus 1, I factor out the radicals with the inverse of the distributive property. Okay. So I'm left with 2 minus 1 is 1, so square root of 5, and negative 2 plus 5 is 3, so 3 cube root of 2. So the expression, the square root of 2 minus the cube root of 16 plus the cube root of 250 minus the square root of 5 is equivalent to the square root of 5 plus 3 times the cube root of 2. The design shows the boards needed for bracing the back of some set scenery. Will 75 feet of wood be enough for all the bracing? Okay. Let A represent the length of the diagonal for the smaller square, and B represent the length of the diagonal for the larger square. Determine the length of diagonals. So 4 squared plus 4 squared is A squared, 7 squared plus 7 squared is B squared. So 32 equals A squared, 98 equals B squared. Take the square root of both sides of the equation and simplify the radical. Since the context is length, the negative solution may be disregarded. So there are 3 edges that are 4 feet, 4 edges that are 7 feet, and 2 diagonals each of 4 square root of 2 feet and 7 square root of 2 feet. Determine the total length of the boards. 3 times 4 plus 4 times 7 plus 2 times 4 square root of 2 plus 2 times 7 square root of 2 equals 40 plus 22 square root of 2. I evaluate it, so it's approximately 71.1 feet. So 75 feet of wood is enough to make the bracing for the set scenery. All right, how can you rewrite each expression in a simpler form? So again, I need to combine my like terms. So I have the square root of 2 plus the cube root of 2000 minus the cube root of 128. So the square root of 2 plus 2000 minus 128. So that's the cube root of 1872. $1,872 plus cube root of 9. Okay, that's 208. 5? No, 208 divided by. Let's see. 176 out, which is cube root. It's 36. That's 18. 72 divided by 36 is 52. 6 times 52. So the square root of 2 plus 6 cube root of 2. All right, so then for B, I have square root of 20 minus the square root of 600 minus the square root of 125. So again, they're all square roots, so I can just subtract 20 minus 600 minus 125 is 705. I'm doing that. Let's do 20. Square root of 20 becomes 4 times 5 minus square root of 600. Four, 3 times 3 times 3 times 2. No. Let's do 5 times 3 times 4 times 2. 600 minus the square root of 125 divided by 5 is 25. So 25 times 5. So I broke all those down. So I can take out the 2 here. Minus 5 times 2 is 10. And I'm left with square root of 6 minus 5 square root 5. Then I can combine my like terms. 2 minus 5 is negative 3 square root 5 minus 10 square root 6. All right, example 5, multiply binomial radical expressions. What is the reduced radical form of the product? The cube root of 7 times 2 minus the cube root of 49. So the cube root of 7 times 2 minus the cube root of 7 times the cube root of 49. I use the distributive property, multiply radicands with like indices. These have the same indices, so I can multiply 7 times 49 gives me 373. Cube root of 373 is actually 7. So I have 2 times the cube root of 7 minus 7. So that is the product. What is the reduced radical form of the product? 2x minus the square root of 3 times 2x minus the square root of 3. I can expand the product. So 2x times 2x is 4x. 2x times square root of 3 is negative 2x square root of 3 minus 2x square root of 3 plus the square root of 9, okay, which simplifies to 3. So I'm left with 4x squared minus 4x square root of 3 plus 3. So that is my simplified radical form. All right, so let's multiply. X minus the square root of 10 times x plus the square root of 10. So this is x squared plus x square root 10 minus x square root 10 minus the square root of 100. So that's x squared minus 10. That's actually a difference of 2 squares. The square root of 6 times 5 plus the square root of 3. So I get 5 times the square root of 6 plus the square root of 6 times the square root of 3. So 5 square root 6 plus 6 times 3 is 18. Square root of 8, or square root of 18 is 9 times 2. The 5 square root of 6 plus 3 times the square root of 2. All right, example 6, rationalize a binomial denominator. How can you rewrite 1 over 2 plus the square root of 5 without a radical in the denominator? So to rationalize the denominator that has a binomial denominator, multiply by the conjugate of the denominator. So what we did back in chapter 4. Conjugate of a plus b is a minus b, so the conjugate of 2 plus the square root of 5 is 2 minus the square root of 5. Multiply the numerator and denominator by the conjugate of the denominator, which gives me 2 minus the square root of 5 over 4 minus 5, which gives me 2 minus the square root of 5 minus over negative 1, which is square root of 5 minus 2. Okay. I can rewrite it as square root of 5 minus 2. All right, so what is the reduced radical form of each expression? 5 minus the square root of 2 over 2 minus the square root of 3. So I need to multiply by the conjugate. So I'm going to multiply by 2 plus the square root of 3 over 2 plus the square root of 3. All right, this gives me 10 plus 5 square root 3 minus 2 square root 2 minus the square root of 6 over 4 square root of 3 times square root of 3 is 9, so minus 9. So this equals 10 plus 5 square root 3 minus 2 square root 2 minus the square root of 6. And this is 3. 4 minus 3. It's 1. So that's why I get that. For b, I have negative 4x over 1 minus the square root of x. So I have negative 4x over 1 minus the square root of x. So I need to multiply by 1 plus the square root of x over 1 plus the square root of x. So that gives me negative 4x minus 4x square root of x over 1 times 1 is 1. X times x is x squared, so minus x. So that is what I get, negative 4x minus 4x square root of x over 1 minus x. All right, concept summary. Product of radicals. Product property of radicals. So the nth root of a product is equal to the product of the nth root of the factors. In algebra, the nth root of AB equals the nth root of A times the nth root of B. Here it is in numbers. You also have the quotient, which is basically saying that the nth root of A over B is the nth root of A over the nth root of B. And rationalizing the denominator. To rationalize the denominator of an expression, I multiply by the conjugate of the denominator. Okay. So the square root of x times the square root of x gives me x. Square root of 5 times square root of 5 gives me 5. Using properties of radicals, so I can find factors that have a perfect fourth root. Since the denominator is a binomial, I multiply the numerator and the denominator by the conjugate of the denominator. Okay. And that is the end of Unit 5, Lesson 2.